solving a value mixture problem using a system of linear equations. So my problem here says two mechanics worked on a car. The first mechanic worked for 20 hours and the second mechanic worked for 15 hours. Together, they charged a total of $2,750. What was the rate charged per hour by each mechanic if the sum of the two rates was $165 per hour? So the first thing I'm going to do here is define my variables, and the question, what the problem is actually asking me, is what was the rate charged per hour by each mechanic. So I'm going to let X be the rate charged by mechanic number 1. And I'm going to let Y be the rate charged by mechanic number 2. Okay? Because that's what the question is asking me. So I know that that's what I need my variables to be, the rates for each individual mechanic. Now, I need to set up two equations. Okay? So the first mechanic worked for 20 hours. Okay? So 20 hours at whatever his rate was, okay, X, is going to be how much money he made. The second mechanic worked for 15 hours. So 15 hours times his rate, Y, is going to be how much money he charged or made for the day. So 15 times Y. Together, they charged a total of $2,750. So I have two kind of words here that help me write my equation. Together and total. Both mean that I'm going to be adding those two terms together, and my total is equal to $2,750. The charges for each mechanic add together to be $2,750. Now my second equation is going to come from this last part. The sum of the two rates was 165. So X and Y represent my two rates. Their sum, or X and Y added together, total 165. So there's my two equations. Now, to solve this system using elimination, I need one set of exact opposite terms, either X's or Y's, but they need to be exact opposites. I'm going to choose Y's only because 15 is smaller than 20, and I like to work with smaller numbers if I can. So if this one is positive 15y, I would like down here in the bottom equation this term to be negative 15y, so that they would be exact opposites. So to get negative 15y here, I need to multiply this term by negative 15. But if I multiply the y term by negative 15, I have to multiply my entire equation, bottom equation, by negative 15. So negative 15 times x is going to change that term to negative 15x. Negative 15 times y will be negative 15y, and negative 15 times 165 for my constant is negative 2,475. Okay, now this top equation, I'm just going to copy it over above this one. So 20x plus 15y equals 2750. Okay, now I'm going to just use column addition and combine my like terms here just straight down. So 20x minus 15x leaves me with 5x. These two terms eliminate, the plus 15y and minus 15y. And then for the constants, 2,750 minus 2,475 equals 275. Divide both sides by 5 to isolate my x, and I get x is equal to 275 divided by 5, which is 55. Now remember, X is mechanic number one's hourly rate, or how much he charges per hour. So we know mechanic number one charges $55 per hour. Okay, now I need to figure out mechanic number two's hourly charge or hourly rate. So I'm just going to go back to one of these two original equations. This is the simpler one, so I'm going to use that one. So x plus y equals 165. And I'm going to replace this x with 55 since I already figured out what the x value is. So 55 plus y equals 165. Then I need to solve for y, so I zero out this 55, or this constant term, and then keep my equation balanced by doing the same thing on the other side. So y is equal to 165 minus 55, which is 110. And again, this is the hourly rate, his rate charged per hour for mechanic number two. So mechanic number two charged $110 per hour.